Hi, this is David Harper of Bionic Turtle. I wanted to briefly illustrate the option Greeks, or the Greek letters as they are known, that collectively tell us about the sensitivity of an option price to its underlying inputs. So to illustrate, I'll imagine some assumptions here that we can use to compute the price or value of a European style call option, a stock option. In this case, the stock price is 100, the strike or exercise price is 100, annualized volatility is 30%, the riskless rate is 4%, and we'll start with the idea that the option has a contractual term or life of 1 year, meaning it, in the case of a European style option, it is exercised at expiration in 1 year. Also, this is a 0% dividend yield, so it's a stock on a non-dividend paying, it's a stock option on a non-dividend paying stock. If we plug these input assumptions into Black-Scholes, in this case we would get a price of $13.75. And the plot here on the left illustrates that if we were to extend the life or term of the option, and out here this would be a LEAP, a long-term option with a 10-year life, we see here on the y-axis the price of the option goes up. So this just illustrates a longer term implies a higher price or more value on the call option. So that's pretty intuitive. Here a more classic diagram of the nonlinear function that compares the stock price on the x-axis to the price or value of the call option on the y-axis. So as the stock price gets higher, we're moving to the right here, the value of the option gets greater because the option is becoming progressively more in the money. So this just characterizes the basic price of the option here. We start with $13.75. Now let's look at the Greeks, which collectively tell us about this value, the sensitivity of this value to these inputs. So this is important for option valuation and for traders. And I've highlighted first the stock price because the first one is delta. So delta tells us the change in the option price with respect to the stock price. If the stock price changes, how sensitive is the option price to a change, given a change in the stock price? It's a first derivative. All of these are derivatives. Almost all of the Greeks are going to be first derivatives. For example, if the delta is 0.6, which would be pretty typical for an at-the-money option, that tells us that if the stock price changes by a small amount, the option price is going to change by the delta, or 60% of the stock price change. So you see how delta is a sensitivity to a change in the stock price? It's the change in the option price with respect to a change in the stock price. For graphs here, I have this plot of delta versus the option life or term. So the longer the term on the option, the greater the delta, the greater its sensitivity to a change in the stock price. And here I have a plot of the delta compared to the stock price, and we see that as the stock price increases, the delta increases. The axis here ends at 1 and starts at 0, so it's bounded by 1 and 0. As the stock price increases, the option becomes progressively more in the money, such that the delta converges and becomes close to 1. As the stock price decreases, the option is becoming progressively out of the money, and the delta decreases and tends to be asymptotic to 0. So we have low deltas when the option is deeply out of the money and also deeply in the money. Okay, then we'll look at gamma now, which is the only second derivative on my list. Gamma is the rate of change of the delta with respect to the price of the stock price. So it's a second derivative or a first derivative of the delta. Gamma is telling us about the rate of change of the delta. And graphically we can see that, well, on the left here we can see that a longer term indicates a lower delta, but more importantly here on the right, the delta tends to peak when the option is at the money, and that's where the delta is changing most rapidly. If you think about that chart we looked at before, it's got the steepest slope right about at the money as the option becomes progressively out in the money and progressively out of the money. The delta over here is converging to 1 but becoming more stable, so gamma is tending toward 0, and over here on the left the delta is converging to 0 and also becoming more stable. Its rate of change is slower, so gamma is also closer to 0. Okay, so let's look at vega, which is very significant because the sensitivity is typically high here. Vega is the change in the option price with respect to a change in the volatility. So a higher vega means that the option price is going to be changing or more sensitive to or more responsive to changes in volatility. And we see that here vega is an increasing function of the option life. Longer the term, the more sensitive this option price is to changes in volatility. Also, like gamma, tends to peak at the money, so at the money options have a higher sensitivity in their price to changes in volatility. Then we look at rho, which is the change in the option price, you guessed it, with respect to changes in the interest rate. So we can see this is also an increasing function of the remaining life or term on the option, although relative to the other inputs, the sensitivity of the option to the interest rate, the rho, tends to be a little less or more modest. An option is more sensitive to changes in volatility as a general rule than to changes in the interest rate. And finally, you can see I'm just working my way down the inputs, so there's a common pattern here. All of these are changes in option price with respect to a change in the input. So finally we're at theta, which is also called time decay, which tells us about what's the change in this option price with respect to a small change in the term. And theta is going to almost always be negative. And that's because if we start out here on the right here, that's where an option has 10 years. As the option gets, as time passes and the option gets closer to expiration, it's becoming less valuable. So time is eroding the value of the option, and as it turns out, the closer that option gets to expiration, the more rapidly that time decay is acting on the option. So it's negative here, and it's sort of an accelerating function as we get closer to expiration. But still, sensitivity of the option price to a change with respect to the term. So we've covered, in just about 8 minutes there, all of the basic Greeks. Delta is with respect to a stock price. Gamma is with respect to delta. Vega is with respect to volatility. Rho is with respect to interest rate. And theta is with respect to remaining life or term on the option. So that's an introduction to the option Greeks. This is David Harper, the Bionic Turtle. Thanks for your time.